Okay, last section in the this chapter that we're going to do is surface area, where we're changing the dimensions and just seeing how that affects the surface area. So how does the area of a 2D shape change when you double the side lengths? Check some examples, then explain a rule. So a 2D shape would be, oops, what am I doing here? Would be like a rectangle, right? So that's just a rough rectangle. Let's say that's 3 centimeters and this is 5. So the area would be 15. Okay. What if I double that? So I make it twice as big, both sides. So this would be 6. I'll do it in red. 6 here, and this would be 10. So that would be 60. Basically, it's 4 times as big. You can see in order to double that, I'm going to have 4 of these smaller rectangles in it, because it's 2 dimensions and I've doubled each dimension. So 2 times 2 is 4. If I triple, this would be 9, this would be 15, and so it would be 135, which would be 9 times 15. So kind of made a mess there. Just going to erase that. Okay, so we've checked some lengths. So when you double the side lengths, the surface area is, we could say, quadrupled, right? 4 times as big. Okay. All right. So Leanna is a carpenter. She is making model pyramid-shaped trees out of plywood for a pavilion at a fair. At the all the pyramids have a square base with sides 4.9 meters long. The slant heights of the pyramids vary from 5.5 meters to 18.2. How much more plywood is needed for the largest tree than for the smallest tree? Okay. So which face is the same on all the pyramid trees? So that we have to remember, the base is not changing. They're just making the trees grow taller, basically. So the base is the same. Which faces increase in size? The triangles. Triangular sides or faces. So what is the surface area of the smallest pyramid tree? So the base area is 4.9. Then we have to square it. And then remember, we talked about this in an earlier chapter, we can, for all the triangular sides, we can take the pyramid, which is 4 times 4.9. And that's basically, if we cut them all out into a net, those would be all lined up, times the slant height. So the surface area of the smallest, 5.5. And of course, there are triangles. So let's calculate that. So 4.9 squared, 24.01. I'm going to do it in steps here. And then 1 divided by 2 times 4 times 4.9 times 5.5, 53.9. Uh, 77.91. Okay. What is the surface area of the largest pyramid tree? So that's 4.9 squared, which we know is 24.01. And then the this is still 4.9, but then the slant height of that was 18.2. Okay, so 1 divided by 2 times 4 times 4.9 times 18.2, 178.36. Plus, what did we say? Plus 24.01. 202.37. Okay. How much more plywood is needed for the largest tree to the nearest square meter? Right. So, yeah, so we're not even quadrupling it or anything right now. Anyway, so we'll subtract that. So the answer is already in my calculator. I'm going to subtract, and then I'm going to go up, or you can copy it out. 77.91, 124.46. And that rounds to about 124. Okay, so really we weren't doubling anything. It was just basically the difference. And then let's take a look here just on the side, because this is a good thing to think about. Why can you ignore the base areas when you're comparing the surface areas of the trees? Can you always ignore the base areas? Well, if the bases are the same, and we're just wanting to know how much more material is needed for the larger ones, really we could have eliminated this, because that gets subtracted out from each other, right? So we didn't have to calculate that. Okay, next one. Maurice is an interior designer. He sees this spherical light fixture that costs $40. Maurice wants to use a spherical light fixture with triple the radius of this one. What would be a fair price for it? Well, if you think about the cost, like I'm assuming it's mostly open, hollow inside, because like it's got to have a light bulb, and then you wouldn't want it to be too heavy. Then really, how you want to think about how much more surface area it requires, and then really, if you're basing the cost on how much surface area, then you would want to change the price accordingly. So it does take you through the steps here. It says what area of glass is needed for the smaller light. So remember, 4 pi r squared is one of the methods for doing that. And so it's 4 pi times the radius, which is 3 squared. So 4 pi times 3 squared is 113.0973. 113.0973. And then what is needed for the larger light? Well, the larger radius, it says triple the radius, right? So we're going to go 3 times 3. So the new radius is 9. So the surface area will be 4 pi times 9 squared. So let's do that. So 4 pi times 9 squared is 1017.8760. Okay, and then what would be a fair price for the larger light? Explain. So how many times as much surface area or glass is it? So if I take that last value and divide by my original surface area, that will tell me how much more, how many times as much surface area there is. 9 times, which makes sense because surface area is a two-dimensional thing. Even though this is a three-dimensional object, surface area is, if we made it flat, like those orange peels, it would be on 2 dimensions. So it's really 3 squared times as much, which is 9. So we didn't really have to calculate all of that. We could have figured that out. So it has 9 times as much glass. So the price would be 9 times 40, which is $360. Okay. All right, so now go do the practice, and that's the last lesson. I think 3.7 is just a puzzle. So do the practice, chapter review, chapter test before your unit test.